In this question, a scientist wants to determine what volume of ammonia gas, NH3, at STP, that's standard temperature and pressure, would be needed to react completely with 0.260 liters of a 2.55 molar solution of hydrobromic acid, HBr. Let's start off by balancing our equation. I'm going to set up a little table with my reactants and products. We've got hydrogen, bromine, and nitrogen. In our reactants, we've got HBr, which gives us one H and one Br. And we've got NH3, which gives us one N and three more H's. So that's a total of 4 hydrogens. Then our products, we've got NH4Br. So one N, 4 H's, and one Br. So this one's actually already balanced. So all of our coefficients are just going to be 1. So I'll enter that over here. Remember, normally you wouldn't need to include the 1 to show we've got one of it, but on this website we do need to include the 1. Great, so our equation's balanced. Now let's think about what we've been given and what we're trying to find. So we've been told that we have 0.260 liters of a 2.55 molar solution of hydrobromic acid. So we know we have 0.260 liters of HBr. And we know we're trying to find what volume of ammonia gas NH3 we have. So we're trying to get to liters of NH3, that's ammonia. Remember, we can only convert between different compounds in moles. So first we're going to have to get our HBr, hydrobromic acid, into moles. Once we've got that in moles, we can convert that to moles of NH3 using our chemical equation. And finally, we can then figure out how many liters of NH3 that is. So we've got 3 steps. And we can go ahead and set up our dimensional analysis table. And we can put our given in the top left. So we've got 0.260 liters of HBr. And we're told in the question that the hydrobromic acid has a molarity of 2.55 molar. Remember, molar means moles per liter. So that's 2.55 moles per liter. So what that's telling us is that in 1 liter of this HBr solution, we have 2.55 moles of HBr. So the molarity gives us our conversion factor for that first step in the dimensional analysis. So I'm going to have HBr on the liters of HBr on the bottom because that's what I'm trying to get rid of. I'm going to have moles of HBr on the top because that's what I'm trying to find. And I'm using this conversion factor so that 1 liter of HBr equals 2.55 moles of HBr. For my next step, I want to get from moles of HBr into moles of NH3. So I'm going to have moles of HBr on the bottom so that that will cancel out, and moles of NH3 on the top. Then we're going to look to our chemical equation to find the ratio between these. We know that 1 mole of HBr reacts with 1 mole of NH3. So for every 1 mole of HBr that we have, that combines with 1 mole of NH3. So there's our conversion factor for this step. It's 1 to 1. So that's really simple. Finally, we want to get from moles of NH3 gas into liters of NH3 gas. And we're told in the question we're at STP. Remember, STP tells us that 1 mole of our gas is going to take up 22.4 liters. So that's going to be our conversion factor for our gas volume in the last step. So I'm going to have moles of NH3 on the bottom so that that will cancel out. Liters of NH3 on the top because that's what we're trying to find. And 1 mole of NH3 gives 22.4 liters of NH3 gas. Awesome. So we've got our dimensional analysis table ready. Everything on top is going to multiply together. Everything on the bottom is going to multiply together. And then we're going to divide top by bottom. So any units that are the same on the top and the bottom can cancel. So liters of HBr cancels with liters of HBr. Moles of HBr cancels with moles of HBr, and moles of NH3 cancels with moles of NH3. So if we calculate that out, we've got 0.260 multiplied by 2.55 multiplied by 1 multiplied by 22.4 litres of NH3. And then we're going to divide that by 1 multiplied by 1 multiplied by 1. So if we put that into our calculator, we're going to get out 14.9 litres of NH3. So let's go ahead and check that now. Awesome. So this question works exactly like the other stoichiometry questions we've done. The only difference is on this one, we also have litres of gas and we have litres of a solution in the same question. So we're using both of those conversion skills. Remember, always start off by writing down your given and figuring out a map to figure out how we get to where we're going. And remember, we have to go into moles first because we can only convert between two different compounds when we're in moles. Then once we've got moles of the other compound, we can convert that into whatever we're trying to find.